Welcome back to Forbidden Knowledge News. I'm your host, Chris Matthew, and today I'd like to welcome creator of the Mobile Observatory Project, SuspiciousObservers.org, Observing the Frontier, SpaceWeatherNews.com, MagneticReversal.org, and QuakeWatch.net, Ben Davidson. How are you today, Ben?
Pleasure to be here. How are you doing?
I am excellent. And the work you do is awesome because you cover the changes in our solar system, the sun, and our planet that the mainstream won't touch. So what got you started on your research?
Well, I had loved science when I was younger. When I went to college, I wanted to be the weatherman. I took a number of meteorology classes, but that is all about towing the line and doing exactly what the professor tells you to do, even though your books are 15 years old and the process of weather forecasting is changing by the month, etc. I didn't have the patience for it, and the professors didn't really have the patience for me. So I have an economics degree, then I got a law degree. By the way, law school is the last place in the world that actually teaches you how to think as opposed to just regurgitate information, at least in terms of academic institutions. There's experience that can teach you that as well. But after going to law school, I actually went into due diligence. I didn't even take the bar exam. I knew I wanted to not be a lawyer. And that basically required to, one, use my economics degree for the investment that was being studied for whatever my bosses wanted to invest in at the time being, use my law degree to determine if there were any statutes that applied, any laws that applied, or if there was any intellectual property like patents that needed to be addressed. But then also, when you're doing what's called due diligence for venture capital investments, you also have to kind of be a quasi-expert in what you're investing in. And so when your boss wants to have a diverse portfolio, with a bunch of different kinds of investments, boy, is that a nightmare for your due diligence analyst, because he's got to become an expert in a whole bunch of different things. And that's really where I rediscovered my love of both chemistry and physics. And I've always been interested in the sun and weather, earthquakes, things like that. And so, long story short, I started doing what I did for a living, except for the things that interested me: the sun, the weather, earthquakes, science, news, things like that, on a YouTube channel. And I was doing it for fun. One day I looked down, there were about 100,000 people watching, and I realized it was time to quit doing this for people who were very, very rich just to get them richer, and start doing something that may actually make a difference somewhere. And my wife joined me.
That is awesome. Yeah, and there's so much going on with planetary changes and changes in our solar system right now. It's really important. I mean, the information that you're sharing is so important right now that we hear about this. And, I guess to start us off, one of the things I want to talk about is, when I was growing up in the 80s and 90s, we were always taught the main force that kind of rules the solar system is gravity, and it's all gravitational. And that's kind of starting to change now with, people researching the electromagnetic side of things. Would you agree?
I would definitely agree. And it's changing at even faster paces the larger scale you go into the universe or the cosmos. So if you want to talk about at the galactic level or at the level where you're talking about clusters of galaxies or superclusters, things like that, it's changing across the board.
Definitely. And what do you think it is that is, you think that it's just the research that is coming along and they're just mainstream science is starting to realize that electromagnetics is the, one of the driving forces from the sun?
Well, there's a whole range, sort of like a sliding scale of opinions on this topic, and they range from science is just doing their best and figuring it out step by step to, for potentially nefarious reasons, the truth about things was sort of hidden for a long time. I come down generally somewhere in the middle. Too many things were classified that shouldn't have been classified. Patents have, in a way, held up research when they should really be an economic thing for the person who did the invention. I won't go into a lot of that now, but the gravity is just such a seductive temptress on large scales for scientists, because it really does allow them to have these broad guesses for the sizes of stars and the sizes of galaxies and how many stars there are, etc., and basically make the math fit so that they can say, hey, this is going to work. Of course, it should have been a real big clue when they missed 95% of the universe and had to invent dark matter and dark energy, that there was something amiss, but they decided to stick with gravity for the most part, rather than look to enhancing the importance or the influence of electromagnetic forces, and specifically plasma, over, again, scales relevant to planets, stars, solar systems, galaxies, and beyond.
Yeah, that's fascinating. And another thing is the sun. It's not what they used to teach us in school. It's not like a nuclear reactor. Talk a little bit about what the sun is and how it actually can affect weather here on Earth and even earthquakes and volcanoes.
Well, first off, I can assure you that they absolutely do still teach that in school. According to mainstream science, it is still a nuclear furnace that somehow just sort of sustains itself into this dynamo of cycles. That's still what they teach kids in school. That's still what the quote experts model, and when they make their predictions and when they try to understand the sun, and when they tell us what's inside of the sun, it's all based on those guesses.
Right.
But there's nothing about a otherwise uncontrolled thermonuclear engine at the core of a star that's going to produce so many of these cycles on the sun that have so many perfect harmonies. One would be the 11-year cycle. Another one would be the 400-year cycle, or perhaps even the half harmonic 200-year cycle, which aren't related to one another but sync up at various times, throughout the longer thousands of years time scale. And these things are really hard to reconcile with this reckless, uncontrolled, as I said, nuclear engine. It's why they invented this dynamo model, they say, that somehow manages to build up energy and then release it over a finite amount of time, and then somehow takes the exact same amount of time to build up just about the same amount of energy, etc. But then you have to look at other things, like the fact that the sun doesn't bulge. At most, they detected a 10-kilometer bulge at the equator. And what I mean by that is, the sun is spinning. It does a rotation every 28 days, about. And therefore, the equator does bulge out a little bit, or at least it should. But the largest they've ever seen is, like I said, about 10 kilometers. And that's over the entire million-mile wide sun. Earth bulges 13 miles. So Earth bulges way more than the sun. And allegedly the sun is just gases, and it's not rock and crust held in place, things like that. Ooh, that presents some very serious problems. And by the way, the 10 kilometers they did say that was their most likely guess, but the error range actually included 0, so as in no bulge whatsoever. So they really don't even know if the sun does bulge at all, which would violate every single rule of known physics, but not perhaps some of the unknown rules of physics, or at least underappreciated ones, or maybe lost or swept under the rug ones. But getting back to the rest of your question, the sun has an unbelievable influence over this planet. Despite what you can hear in mainstream schools, on mainstream news, and mainstream newspapers, the sun has been responsible for hundreds and hundreds of scientific studies, the same kind of rigorous and reviewed scientific studies that, quote, global warming and climate change have gone through. But they don't count as climate change because they're about the sun and the earth, and not just about man's influence. a neat little trick that the UN's IPCC uses. But without getting too much into that, the sun, all it really does is affect Earth electromagnetically. That is the primary influence. Whether it's the ultraviolet, the X-rays, and the other wavelengths, or it's from the particles, whether it's the solar wind or the more energetic ones that come out in the big solar blasts, like when there's a solar flare that produces a coronal mass ejection, something like that. And what these really do is all of this energy is deposited into one of two places, either the magnetosphere, about 25 to 40% of it, or the ionosphere. Now, what these are magnetic and basically electric shells that go out from the top of the atmosphere. So if you go up to the top of the atmosphere, the ionosphere sits on top of that. Actually, is about a few hundred kilometers wide, and then way out beyond that, it would be the magnetosphere. Those are what actually take in the energy. Now, the reason why this is important is because they funnel that energy and transform it really into more of a water vapor and dust attracting electric current and static current, a lot like a Swiffer duster or any kind of other static duster you might have in your home. And these currents basically either feed directly down through the atmosphere and into the crust via the magnetic fields that do so, or when they juice up the ionosphere, they trickle down through what's known as the global electric circuit, and that's how you get direct energizing of hurricanes, typhoons, cyclones, and there are now more than 25 scientific studies published on this, many of them with authors from NASA, Johns Hopkins, MIT, Princeton, Yale, Harvard, Stanford, Berkeley, Caltech, all of the top places you could name. And yet they don't get any of the press that the human side of climate change studies get. And yet they show that they're every bit as important, if not more important, when we're talking about the sun. The influence over clouds, global temperatures, precipitation, things like El Nino and La Nina, and everybody knows those, but there's tons of other ones all over the world, like the North Atlantic Oscillation, the Southern Annular Month, that are very important. The monsoon tracks in Asia basically determine whether or not those billions of people are going to have food or not, and those things are highly variable based on solar activity. So it really does have this effect, and it doesn't just affect the weather, as you very adequately mentioned. It also affects things like earthquakes and volcanoes. In the case of earthquakes, we're talking about major disruptions that happen in crystal-rich, water-rich, three highly conductive, by the way, things, areas of the Earth, and the areas where this energy definitively comes down in either the magnetic fields or the global electric circuit. The ionosphere and the magnetosphere are the finished ceiling and the insulation of the room. The crust of the Earth, and perhaps even the mantle, is the floor of the room, and the floor of the circuit, I should say, and the ceiling of the circuit. And so we know that it does go down, and it does influence the mantle as well. And in addition to knowing how it works electrically, the number of statistical studies that have lined these things up, things happen on the sun, boom, 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 these things happen on the Earth. And that's actually one of the ways we got started with this. We started looking at the sun, earthquakes, weather, and a number of other things every single day, not intending to do anything other than just report them in an interesting way, try to get some good footage, use the best satellite images that were out there, make it look pretty. But all of a sudden, it was like stuff a third or fourth grader could realize, wait a minute, every time this happens on the sun, this happens in the weather, and this happens in the ground. And so that's what the books have been based off of, the app is based off of, our two papers are based off of. And so you really summed it up there, and I suppose I just sort of dribbled on for a number of minutes.
No, that's great information.
But I suppose the very last piece of it would be the volcanoes, and it's been shown now in three very impressive studies that higher cosmic rays, whether they're coming from the galaxy or it's the highest energy particles from the sun, those are the ones that do make it down into the mantle. And if you guys have ever heard of those tiny particles that are so energetic that they can actually make it to the core or fly through the entire planet and not hit anything, those are the kinds we're talking about here. They mostly interact with the mantle, and they change the viscosity in a very significant way. And so they noticed that not effusive, but explosive volcanic eruptions are strongly tied with this. And it all makes sense electrically. It's just that, I mean, the ability to monitor cosmic energy and at the same time begin to understand its effects on liquid rock, you know, miles beneath your feet, on atmospheric processes that that most weathermen admit are, meagerly okay at best. It's a very difficult task. It really is. But it's amazingly coming together from all different places in science. It is unfortunate that it's not getting as much of a voice in the news, but it's pretty clear that it's getting at least a small voice with some science happy laymen on the internet, I would say.
Right. Yeah. There is some hope with some of that, and you've actually been able to predict some major weather events and earthquakes. Is that correct?
Right. The best weather prediction we had, if anybody remembers back in 2017 in September when those hurricanes ravaged Puerto Rico. It actually started with Hurricane Harvey hitting Texas, and then, I think there was Irma, Jose. I'm forgetting one in there somewhere. But when Irma formed, that was when we had the strongest of strong signals from the sun that the storm would intensify and drive westward as hard as it could. And it looked like there were about 4 or 5 days of this left in the sunspot. And there were only 3 days left of westward charging in Irma until it hit Florida. Now, because no weather model on the planet uses the sun, literally every single model had it missing Florida to the east, running up the Atlantic coastline and hitting somewhere between, say Jacksonville and Maryland. They were all over the place when you got there. But I said definitively, look, unless this sunspot just shuts down and stops firing solar flares, this thing will enter the Gulf of Mexico. And of course, that is indeed what happened. And literally the day it turned north was the day that sunspot finally, the way we say it, crested over the limb, which basically means in the sun's rotation, the sunspot just rotated out of our view. Kind of like we do. If you were standing on the sun looking at somebody down on the earth all day, well, the earth's rotation is going to take them out of your view at nighttime for that person anyway. So same kind of thing. That same day is when Irma turned north. In terms of whether or not a tropical storm is going to intensify or fade, whether or not a storm is going to march northward or southward or hold its track, those things have been very, very successful, very, very successfully predicted just using the sun. The earthquakes are a bit harder because you have to use the weather and you have to use infrared sensors on a global scale as well, in very complex ways sometimes. But yeah, it has been done. You mentioned QuakeWatch.net at the start of the show. That's a really deep topic, but a lot of it is there and actually pretty well synthesized concisely at that website. So I would say that's a pretty good resource for electromagnetic quake forecasting.
Very good. And one of the things that we definitely need to talk about, it's actually been in the mainstream news a lot lately. It was, I think, a lot towards the beginning of the year that our magnetic north is actually rapidly moving, and it's sped up a lot. Let's talk about what's happening there.
Right. So every time they do one of these updates, at least for as long as I've been watching, they always predict that over the next 5 years, this rapid pole acceleration that we're seeing is not going to happen. It's going to either stay the same or it's going to slow down. The prediction made back in 2015 was that the pole would in fact slow down its motion slightly. It would still be tracking a number of kilometers per, in that year or in those 5 years, but slightly less quick than it had been. And that didn't happen, but the world magnetic model that they had published for the entire world was based on that guess, as it always is. Now, normally, that guess doesn't change the fact that the model is relatively accurate. It doesn't go outside the 2% range of error. This time, it did. And so that really does indicate that their model for trying to predict reasonable yet non-scary pole motion, magnetic pole motion, needs a little bit of an adjustment, because this thing really is hustling now across the Arctic Ocean, at least in terms of the North Pole. And it really has to in terms of catching up, because the South Pole is way ahead. Kind of like the tortoise and the hare. It's almost like the South Magnetic Pole is moving so slowly, but it has already left the continent of Antarctica. It's creeping up into the southern Indian Ocean. It actually started its journey about 200 years earlier than the North did. And so the North has a long ways to catch up. Imagine if the tortoise and the hare are sitting there at the starting line. Somebody says go, and the hare just says, you know what, I think I have time for a nap right now, about a 200-year nap right now. And that's essentially what we're seeing. The tortoise has crept into the southern Indian Ocean and is well ahead. The North Magnetic Pole still basically is going past the geographic pole right now, and speeding up as it does so. What happens next is of course the big question, because we know that poles meander sometimes, not usually this quickly. And we know that when they meander, they don't usually start dropping the total field strength of the planet. But that is indeed what's happening right now. And the only time we really see that happening is when we're actually in a major magnetic excursion or a full magnetic reversal, both of which, by the way, have mass extinctions tied to them. So it doesn't really matter which. And so that is basically what we're looking at. In terms of the strength I mentioned, we peaked out as a planet in strength about 3,000 or 4,000 years ago. The magnetic field was very strong, but it actually was not much stronger than it is today. The fade off was very, very slow. It's like it hit that peak, stayed there, dropping very, very slowly. And it really didn't accelerate until the middle of the 1800s, such that we know that from about 1850 or so to the year 2000, we lost about 10% of Earth's magnetic field. They updated that number to 15% just a few years later. And so we know that, what took about 150 years would now take only about 20 years. Was the next one only going to take 10 or 5 years to lose that much of the field? And when you start to lose too much of the field, all those things we just mentioned, the connection with the weather, the connection with earthquakes, the connection with volcanoes, guess what? The only thing standing in its way is the magnetosphere. It's our protective interface with energy from space. And without it, the sun and cosmic rays have complete control over the atmosphere and over the crust and over the mantle. And that's really just not a good thing, because it gets angry. At least the sun does all the time. And even if cosmic rays can't really be personified, just their existence is basically, it turns the mantle angry, I should say. And so in addition to that, in a magnetic event, when you get down to what they believe could be as low as 5 to 10%, boy, everything on the planet is at major UV risk. Everything from insects to flowers to leaves to obviously your skin. Photokeratitis burns even on dark-skinned people and well-haired mammals. Even if we're talking about things that live in the sea, which are shielded from the UV, the microalgae at the base of the food chain, is not. And so they've shown that it has significant vulnerability potential to UV rays. Not to mention that microalgae under strong magnetic fields gets larger and more nutritious. So with less magnetic field on Earth, it would be smaller and less nutritious and under UV stress, which is quite a base of the food chain for the entire ocean. Not only what's going to happen to plants and the insects. So, this is why.
Ben, hold on. You're breaking up there. Just back up a little bit.
So you can see why there's all of the stress on different parts of the food chain, but also nature begins to attack because the weather, the earthquakes, the volcanoes, they do things that just don't happen when Earth's magnetic field is strong.
Now, magnetic reversals have happened many times throughout our history. Let's talk about the possibilities here that could possibly knock us back technology-wise to the 1800s, right?
No, it could be a lot worse than that, my friend. It could knock us back to 20,000 BC.
Wow.
The sun could do that all by itself if it fries the grid. If the sun puts off a couple of major solar flares, even during, when we have a strong magnetic field, if it really gives us everything we've got, every copper wire will melt, no car will be usable, no factory, no machinery, no phone, no air conditioning, heat, no storage, nothing will work. Everything will be gone. And most things that have those wires in them will burn to the ground because of it. We are at a level of vulnerability that we have never been at before. And all of the science says that this happens about every 200 years. Now, the last time it happened was 1859. All there was telegraph wires. They call this the Carrington event. The telegraph wires caught on fire. The operators got shocked. And when they unplugged the machines because they were catching on fire, the telegraphs kept coming in. It had all the electricity it needed to stay on. Now, unfortunately, today, we use much smaller components that are designed to use less energy, energy efficient. They can't handle overloads. They will burn. They will explode like we've seen these batteries do in phones and other things. That's the kind of stuff we're talking about. And the sun can do that. Like if the sun did it right now, just in a couple hours, that's Earth with just about every structure burning to the ground except pyramids and mud huts. With a magnetic reversal, it's much, much worse because in that case, the sun is also taking control of the atmosphere, taking control of the crust. And one thing we know from the surge deposits and fossil records and the ancient stories is that there are great inundations of the sea. Basically, it seems like the ocean just comes out of its bed and attacks the land. And the wind does the same. And all of the cultures that describe surviving something like this, and this would be a magnetic excursion, not even a full magnetic reversal, by the way, because that's the last one we had about 12,000 years ago. All the stories and all the petroglyphs, the cave paintings from that time that we think are describing an unbelievable catastrophe that they somehow managed to survive and felt it was worth remembering through time in the rock. There are solar images all over it that really would be what an ancient person would think to draw if the sun just started to go ballistic with solar flares or worse. I've come to believe that our sun may be a long-term recurrent micronova. And this is going to hit your ear very strangely at first, but let me just sort of pitch it to you. We know that there are 11 recurrent nova in the Milky Way that we know about, one in the Large Magellanic Cloud, and one in Andromeda, for a total of 13 recurrent nova. These stars go boom again and again in nova style. Now, they're not supernova because the star isn't destroyed, but they're at a lower class of it. Now, what astronomers tell us is that they are 99.999% certain that that list will do nothing but balloon over time. We have only been watching for about 100 years, and these things span the range from going boom once a year, which would be the one in Andromeda, to once every 96 years, which would be they saw a nova a long, long time ago, and they actually just saw it go boom about a decade ago. And so they just realized, oh, wait a minute, that one's a recurrent nova. Well, they say the list is going to grow because these things probably have very, very long cycles that we don't know about as well. They say that many of the nova that we have cataloged in the cosmos now will go boom again someday, and we will realize that, that was a recurrent nova. Let's watch for it again. And they also believe that there are some with hundreds to thousands, if not longer, time scales that we have not even seen nova once. And if we were to see that happen tomorrow, we would not know for hundreds to thousands of years more that it was a recurrent nova. That is official mainstream science. And so the question is, at that point, how do you know the sun's not one of them? And based on some of the nova that we do know of and we do see, some of the smaller ones, they're not solar system killers, which makes me think that over the long, long scale and the things we haven't seen in the cosmos, some of those long-term ones might put out even smaller nova. I have no way of knowing because the sun images that are carved and a lot of the evidence, and a very, very convincing guy named Doug Vogt, who's put together literally decades of work on this stuff with a group called the Diehole Foundation. It's exceptionally convincing, and you can't really turn away despite how much you want to, and despite how much I wanted to for the majority of my entrance into this hypothesis. But something like a major solar event, a major super solar flare, or literally a micronova from our star seems to be blamed on all of these catastrophes. And that's where a lot of the evidence seems to point in a lot of the cases. And what's more interesting is we have magnetic reversals correlated with those timelines as well, which makes you ask, is it the sun and something going on with the sun that's aiding or triggering the magnetic reversal of our planet? And then you realize, well, wait a minute, the Earth has been in this cycle and has been sort of changing its magnetism for quite some time, and we're obviously not seeing a major solar blast. We didn't get one to start this. Well, what could it be? Well, I have a question. Have you seen any of the catastrophe cycle videos?
I don't believe so.
Okay, so are you familiar with the Adam and Eve story that was classified by the CIA?
I was actually just about to ask you about that.
Right. So the Earth Catastrophe Cycle series is a 23-episode series on our YouTube channel, basically starting from that point and investigating scientifically in all the different rabbit holes that we could dig. And so essentially here are the facts. At a time when literally people had been writing about this global catastrophe for hundreds of years. Just a few years earlier, a well-known professor named Charles Hapgood and Albert Einstein had sort of worked together to publish their own theory of how it worked, not questioning whether or not it happened, just what was the mechanism? Why did Earth have this repeating cyclical catastrophe? Right at that time, one version was classified, and it was called the Adam and Eve story by Chan Thomas. Now, this version is a very fanciful, theatrical, almost 2012 movie type manuscript.
Right. That's what I thought whenever I heard you reading it.
Right, and that that didn't strike me as something that was going to be very fun to look into scientifically, because it seemed to me to be a bit of hogwash. And I was thinking to myself, why on earth would this get classified? I mean, what is the purpose of hiding what will hit everyone else's ears, just like it's hitting mine, like a complete fairy tale and like complete nonsense? What is the purpose of classifying this one? And the answer came in what they didn't declassify, because they only declassified 57 pages. This thing was sanitized beyond belief. The full version includes a postlude and is about 200 pages, and actually is almost like 3 books crammed into one. And it's what they didn't decide to declassify just in 2016, when a Freedom of Information Act request somehow managed to get the book dug up, and they only let out those 57 pages. One of the things that they had kept behind the wall was the notion that it was a galactic trigger. And what was amazing is we found that original work, the original 57-page release, and then it took a very long time for us to actually find one of these books, a book that was more complete, and send somebody to get it, and then make a PDF out of it. And it was literally months before I ever even knew the first word outside of those 57 pages. And we were already, I think, 19 or 20 episodes in, looking in a number of different directions. But one of those directions was this idea that, wait a minute, we can't deny the fact that the sun seems to go boom here. And since the magnetic reversal of Earth can't trigger the sun, it would have to be the sun triggering the magnetic reversal of Earth. What do we account for in the fact that the cycle seems to be already starting on the planet? And the only idea we could come up with was that we were crossing the heliospheric current sheet, basically at a galactic scale, though, the galactic current sheet. Now, let me tell you essentially what this is. Folks who were around in 2012 might remember this idea that we were going to cross the galactic equator and go from north magnetism to south magnetism, and it was going to basically flip the polarity of the solar system, flip the polarity of the Earth, and we'd have a magnetic reversal.
Right. Yeah.
Well, unfortunately, and nobody would listen to me back then, there is absolutely no such magnetic barrier at the exact equator. These things do exist, but they ripple, they wave out. On the sun, it has a very strong ripple such that the planet Earth, in that 28-day rotation that I mentioned, we get hit with the north fields of the sun, then the south fields of the sun, then the north fields of the sun, then the south fields of the sun, every 28 days. It's about a week we spend inside of each polarity of, even though we're not, crossing the equator of the solar system all those times. It's just the fact that this rippling sheet is moving much faster than we are. Now, and all you need to know to clarify that is it takes us 365 days to go around once. It takes the sun 28 days to go around once, which is why its magnetic current sheet hits us as opposed to us crossing something. It's never us crossing something. And so it's not the sun or our solar system crossing something, because it takes us millions and millions and millions of years to go around the galaxy, not to mention the fact that we are about 17 million years north of the galactic equator and still going north. And so nowhere near. But it doesn't matter if we're a little bit north, a little bit south, because the center of the galaxy is spinning a lot faster than that. Trust me, it doesn't take, millions and millions of years for it to do one rotation. which means that its current sheet is going to hit us, not we are going to cross something. And so what does this current sheet look like? Well, now instead of picturing the little tiny room I mentioned before with the ceiling and the floor, imagine that there are no walls and just the floors go out forever and the ceiling goes out forever. And now imagine it's in a wave. Now the ceiling is an electric barrier. The floor is an electric barrier. And there's an abundance of charged particles, dust, asteroids, and other large objects, kind of like you'd see in the rings of Saturn. That stuff's going to accumulate within that area as well. To the north of that little room, if you could break through the ceiling, it is much less dense, but you're exposed to the powerful northern magnetic fields. That central area is kind of a null zone. If you could break through the floor, you'd be exposed to much less dense area and the powerful southern galactic magnetic fields. But in the middle there, things are very different. Magnetic field strength begins to weaken as you head towards that central point. There's more charged material. There's more dust. There's more impactors. And so for the sun, it probably wouldn't happen until we actually cross that exact central point, or maybe until we bust through the other side, or the other side busts through us, I should say, and we come into the other hemisphere's magnetic fields. But the moment we entered that current sheet, that little room I mentioned before that goes on forever, as we are breaking through the ceiling and going towards the floor,
right
in there, that's when Earth's magnetism begins to change. And so it's the kind of thing where it all does lead up to a crescendo, but there are processes on the sun that are leading to that major event that we don't necessarily see now. Or maybe we do. Maybe it's those cycles, like a clock. And when they do sync up on the longest of scales is when it happens. That's how you make the grandfather clock go ding, by the way, or dong, or however you'd like to think of the grandfather clock. Well, what makes the sun go ding or dong? It's not every time the little hand runs all the way around. You have to wait for, how do you make this thing go ding 12 times, the big ring? Because we know that the sun on these smaller scales, it has smaller scale flares as well. At 1 o'clock, at 3 o'clock, at 7 o'clock, yeah, there's dinging going on from the grandfather clock, but it's nothing like what happens at midnight when everything finally syncs up. And so what's amazing was when we finally got our eyes on that postlude and we saw what the government first initially classified, and two, when they declassified the thing, still didn't deem fit for our eyes. It was that exact same idea, except Chan Thomas was using the very, very old concept of a magnetic null zone. It's not an inaccurate qualitative way to describe it, but in fact, it is the galactic current sheet. And the moment I saw magnetohydrodynamics and I saw magnetic null zone in the postlude, I knew exactly that he had come to the exact same conclusion, that the same thing that we know for an undeniable fact happens to the planet Earth as the sun's magnetic field and current sheet whip around the solar system will happen to our sun as the galactic version of it hits us. And it's not us crossing something. It's going to hit us. And basically we're either going to, bust or enter that, quote, magnetic null zone. It's really an electrically charged area. There's not as much magnetism because it's being taken up by the dust and attracted by the plasma and other things like that. It's in more matter form rather than fields and energy. And so there's a serious question about how long we have until this happens, because scientifically it almost has to happen. And just to give you an idea of what this will do to the sun, happens to the Earth, it can actually cause a full geomagnetic storm. There can be minor GPS disruptions. There can be strong auroras, the northern lights. We notice voltage induced in the ground and in the atmosphere. And we're talking about that on a galactic scale for the sun, which only puts out electromagnetically. And so the best description of what happens when Earth gets hit by the suns is an electromagnetic disruption, an energizing of the Earth. I don't see why it would be any different when it happens to the sun on a galactic scale, and it has to. And it's the only way to account for all of the evidence that people have been trying to put together, literally since the late 1600s. There have been names who have been doing this, through the 1700s, 1800s, and it included Albert Einstein, who, again, didn't even question whether or not this thing was real. It was just, how does this happen? Because the evidence that we do see is so preposterous. Every 12,000 years or so, if you wanted to broaden that scale, every 10 to 15,000 years, something literally, planet, a ride that it can barely handle. And it is amazing that humans manage just to come out of it, actually. But the amazing thing is that we do manage to survive every single time this happens. And we have records of this 12,000 years ago, 24,000 years ago, about 36 to 40,000 years ago. The next ones are kind of weak there, but 72,000 years ago is very strong. The 84,000 years ago, and then the one that's like 115, the Blake magnetic reversal. That one must have been absolutely horrendous. That one actually began the last glacial period of the planet, which was quite an unfortunate thing for anybody who happened to be on the planet at that time.
Now, super volcanoes, should we be concerned about any super volcanic eruption in the near future?
I have concerns about Santorini in Italy. I have concerns about a couple along Oceania and Indonesia. I don't have very much good news for the United States, but one place I have good news for is I think Yellowstone's broken. It's the only super volcano that has the pressure release system like it does. It releases its pressure with minor quakes that are spread out and really diffuse. It releases enough geothermal energy to melt roads every single summer. Not to mention, it has all of those geysers. I mean, it's not the only place in the world that has geysers. It's the only super volcano that has this many geysers and this much pressure release system. I think that the last time it blew, it may have actually broken itself. It may have destroyed too much of the crustal area, too much of the subterranean area. There's a lot of the evidence that there's a downflow of magma, if there's even a very strong chamber there to begin with. It could just be that when it erupted last time, it was a true surge from the deep mantle. But it's not going to matter. If Santorini goes, if one of these ones in Oceania goes, it's really just not going to matter. It's going to be the same kind of thing. The world will not see the sun very well, and that goes for the plants and everything else that require it for quite some time. Certainly long enough to drop the temperatures on the planet in a significant way. I don't know how bad it would have to get for one of these super volcanoes to actually blow in terms of cosmic energy. I do know right now, none of them are really rocking and rolling. Somehow, for some reason, there are always enough new people looking into Yellowstone that the earthquakes that happen there from time to time are always a big deal. A couple of years ago, the folks got real lucky with their storytelling because the seasonal animal migrations happened at the exact same time as one of their semi-annual earthquake swarms that they get there twice a year or so. And so people were like, oh my God, the earthquakes are happening and the animals are fleeing, not realizing it was the seasonal migration. Yeah, Yellowstone is, for example, not as worrisome as Long Valley. I can't say I'm not worried about Long Valley if we're talking about volcanoes. And what does it really matter if it's Yellowstone or Long Valley? But, the kind of things that I worry about in this event really more so are, smaller eruptions of volcanoes, but things like the plates cracking together. Because think about something for a minute. We've got rock that is full of water and air, actually, and it floats on top of the mantle. And the mantle is liquid, but it doesn't act like we're floating on a liquid. The plates don't crash into each other, with every turn of the seasons. I mean, if you think about how the seasons go with regard to the if it was really just crust on a free liquid, the plates would be crashing into each other and crashing over each other and being pushed down into the mantle, and things rising up out of the sea every season. But that's not how it happens. There's actually this tiny little area where they meet, where it actually acts like plastic. So imagine if I challenged you to lay down a sheet of saran wrap and then lay down a second sheet of saran wrap flat right on top of it. And I challenged you to separate them, not by peeling them apart, but by grabbing the corner of one and trying to drag one across the other. You're never going to do it. I don't know if you've ever gotten saran wrap stuck together. You can barely get it stuck together, like a small crease. The point is that that's how that somehow manages to act right now, even though it's rock on liquid. And it's because of this strange thermoelectric equilibrium that can be easily disrupted either temperature-wise or electromagnetically. And when that happens during either the electric field saturation from the solar burst or from the magnetic reversal itself, then the plates do begin to start knocking into one another. And that is how you get the stories of mountain ranges colliding and being created in a day. It's how you get the stories of, imagine the plates flowing like that. It's how you get the stories of the sun standing still for a little bit in the sky and then maybe even going the other way before it regains its traction. There's a story of the long night where they thought that the night was never going to end and the sun was never going to come. By all their estimation, it was 10, 12 hours late. The only way to do this is that literally that lock that the mantle and crust have at the low velocity zone, they call it, between 80 and 200 miles down or so, or kilometers down. When that gets disrupted, these plates can twist and turn and do all kinds of strange things. And the stories of Atlantis, Mu, and Lemuria are probably not invented. These lands were probably above the ocean 12,000 years ago, and then they sank into the sea. There are areas that are exposed now that almost certainly were not exposed back then. There are evidences of enormous deep sea canyons that cannot just be turbidity currents. These things are cut through hard rock, thousands of feet for thousands of miles, as if there was no water there, as if the oceans had left their beds and then they were rushing back into them off of the land. This is really the story of what happens to this planet. It's the story of why new species pop up so randomly as they do. There's DNA bottlenecks that proliferate in interesting ways. And the energy on Earth is different, and that has effects on our DNA as well, both good and bad. And so, I don't know, where do you want to take this from here?
Well,
because
where I want to go is, with all that being said, I want to know, is the mainstream media, just being silent on this on purpose, or are they gonna just not ever tell us that this is a possibility?
Well, they won't do it before the scientists do. There's no chance of that. The media didn't invent global warming and then the scientists came up with all of those papers. That's not how it happened. In a lot of ways, how global warming played out was invented by the media, but you know what I'm saying. The science did actually come first, and so basically what we have is we have interdisciplinary science where everybody making every little piece of the puzzle discovery has had to have their head down, eyes focused, body in a box, look nowhere else, deadline focused in order to be making stride in a specific field of science. They don't have time to be looking around. They don't have time to be trying to draw things together for a bigger picture. They're struggling to get grant money and postdoctoral students, and they're trying to get tenure, and they're trying to sell books, and their salary is crap. And that's what we're dealing with. These people, so there's, at a given university, there's no chance that the astronomy department and the physics department interact at a significant degree unless they're actually writing a paper together. At NASA, people at the Jet Propulsion Lab don't talk to the people at Goddard, and they don't talk to the people at Ames about these things, and they don't talk to the people at Johnson, and they don't talk to the people at the national labs. Every national lab is independent. We've got one at Caltech, Berkeley, Los Alamos, Oak Ridge, Princeton. They all do these things independently, and they don't really talk to each other a whole lot. What it has taken is somebody like Doug Vogt, who I mentioned, who is an accountant and a researcher, somebody like me, who's an economist, a lawyer, and major science geek, and a researcher, to not, spend our time doing the kinds of things that could make a major breakthrough in a very, very complex subfield specialty of science. But no, somebody has to take a Renaissance view and look, step back and look at the whole picture and start putting the puzzle pieces together. Because after Charles Hapgood and Albert Einstein's specific hypothesis was debunked, nobody did it again. It's like science completely forgot it, to the point where most scientists don't even think this is really possible. It's almost like it's below willful ignorance, but they won't even look at it, truly. And so there's no chance the media is going to say a word about this before science does. And science isn't built to do this. Science is built to have ants doing a very specific job and doing it very well. And then people are supposed to come buy the patents and then sell stuff to people through advertisements and fancy posters and other things like that. That's how being worked, how science works now. And there's nobody doing this Renaissance view. There's thousands of new discoveries and hypotheses and interesting and conflicting observations every single year. The major models of the universe don't include them. It's too much to handle. The supercomputers required just to do this once were unfathomable. And now they've got to account for what is literally tens of thousands of new observations and equations coming out on a monthly basis. The task has become covertly unmanageable, covertly unwieldy. And by covertly, I mean they're not telling the world just how unsure and scared and screwed they feel. Not that anybody, gave them a raw deal, just that position. They've dug themselves such a hole in this. And it's not through anything nefarious necessarily. It's just that this is just what happens when you follow the wrong path too long. Eventually, one note can destroy a whole symphony if it's off. And that is what we're looking at in science right here, to the point where make you say, oh, let's just wipe the slate clean and let's start again. And in a lot of ways, we kind of have to get these things right. And since we don't have the guts to do it ourselves, the sun and the galaxy are going to do it for us.
Now, do you think it's like in the movie 2012 where the elites have their underground bunkers ready and they're prepared and ready to go at any time?
The people who got fooled into building, these super expensive ones, the people who bought missile silos, those people are in major trouble. They're not going to survive what's happening. But there's a reason why there are enough mountains hollowed out and tunnels in the United States to fit half the population. And that's just what we know about. We're not supposed to know about any of it, but the stuff has gotten leaked. You can't exactly hide the entrances to Cheyenne Mountain and things like that. People admit that they work in the underground city in Los Alamos, things like that. So I can't imagine what we don't know about. There is all the evidence in the world of massive preparation and massive secrecy, and I can understand that. If I was them, one, I don't want people asking questions. I don't want you guys interfering with us trying to save your lives. And three, things are going to be really, really fun after this. I don't know if we're actually going to make it. You have some fun while you can. People don't generally like that idea. People take a lot of comfort in the notion that government is evil and that every single elite is evil and there's this plan that's like out to get them. It's a fun little fantasy that I explored and researched, and I will admit now, wanted to believe with all my heart. But unfortunately, it only applies to about 20 to 30% of the elites, and not the ones in power either. It doesn't mean they can't do some very bad things, and they do. But for example, George Soros isn't the president of any nation. He doesn't control any secret society. But people like him and the Rothschilds are all you hear when you talk about like elites and things like that. Even when they talk about corporations this, corporations that, I always end up hearing the Rothschild's name and George Soros brought up. It's interesting. I went and I tracked back the initiation, when that actually started on the internet. The bombardment of those two names as being evil players happened the same week. And it happened a day after they both pulled all their money out of oil and really pissed off Rockefeller. So are they on the same side? Is it a coincidence that those things happened the day afterwards and the day after that, the Rothschilds and then Soros? Was that them getting spanked? Are we still getting spanked today? It's not like the Rockefellers aren't getting spanked and big oil isn't getting spanked and all the corporations aren't getting spanked, at least in our discussions, but I don't think they really care about our discussions. It's not like we're on Fox. It's not like we're on NBC. And it's not like anybody really listens to us because we use emotion and screaming when we're online and we're making our points instead of facts and logic and calm arguments. I guess the point is I see every evidence in the world of them thinking we are stupid children. Whether they feel a parental guidance over that, or they see us as cattle to prop up the top of the pyramid even higher, doesn't matter. They clearly are storing enough space and food and seeds and other things to make sure we don't die, or at least they're going to try. And there's no evidence, not one piece to the contrary. There's plenty of idiots online spouting things to the contrary, but there's not any actual factual evidence against what I just said. All the evidence suggests they know what's coming. All the evidence suggests they're preparing for what's coming. All the evidence suggests that they have way, way, way too much preparation and space for what they publicly admit to be using these things for. And this thing happens about every 12,000 years, and the last one was somewhere between 11,900 and 12,000 years ago. So that's really what's going on. Now, I don't like the idea of being in Cheyenne Mountain. I don't know how much I like the idea of trying to find a cave that I knew was a million years old and has survived half a dozen or more of these things. and I can bet we'll survive it again. I won't have any guarantee it won't get flooded with lava or water, or I won't be buried under houses. And why they've been inventing those lasers that can cut through ice so efficiently. I don't know.
Right. Now, for the last few minutes that we have, why don't you talk about some of the ways that we can individually prepare for what's going to happen?
Right. So, man,
Wait, Ben, you're breaking up a good bit again.
No, I apologize about that. So
It's okay.
if we consider that not everybody is going to be able or willing to follow a military person underground, because there's a lot of people who would never do that in a million years. There is evidence in the petroglyphs and otherwise that people survive this thing all over the world. And here we are talking about it. So ancestors, or we are both the descendants of survivors. We have survivors in our ancestors before them. Literally, we are just survivors after survivors after survivors. That's what our DNA is. Somehow, with all the things that go extinct, we have survived these things time and time again. None of the other large mammals survived the last one. Basically, all the megafauna are gone. Very, very few things survived the last one. And so what you have to know is there's going to be lucky people all over the world. Vast majority of the lucky people all over the world are going to be petrified. And then there's going to be a few of the lucky who are going to be prepared. And that involves more than just what you think of normally happening: food, water, perhaps weapons, clothes, provisions, seeds. Make sure that you don't rely on anything that's digital or requires batteries or electricity, because we're probably not going to have it. But also maps and books that can tell you information that you're going to need. You need to know where your waterways are. You need to be able to, if you have to exit quickly, be able to find the mark and then look on a map and know where you're ahead. Know what happens if you turn right, turn left. Books on what plants are edible. Books on, if you could find a book on local mines of your state, or local caverns and caves of your state, buy that book. Especially if it's got a map that tells you where they are. Things like that. Stuff that you couldn't possibly cram all into your head, right? Pre-industrial farming, natural childbirth, the physician's desk reference, all the things that you won't have access to.
Right. All right, Ben, you're breaking up again.
Oh, I'm sorry about that. I don't know why that's happening. I'm not moving. But yeah, essentially all the things that you won't have if and when this happens again. And I suppose, I shouldn't say when, because for all I know, the Earth might be sick of this cycle. For all I know, the Earth is alive, and it's going to send the magnetic poles back to where they belong right now as I'm talking to you. That's not where I'm putting my money. I'm putting my money on the history of Earth, the cyclical nature of the Earth and the sun and the galaxy, and on everything that's been happening for the last few hundred years. Our ancestors who told stories and were smart enough to survive somehow. And they told us what happened to them. We should really, really listen, because we built literally geometry, architecture, philosophy. Our entire world is built on the knowledge of some great, great geniuses in the past. And yet we take what they claim is their most important story and we treat it like a fantasy, like they made it up. But they didn't make it up. All they did was blame gods because they didn't know what else to do. They didn't have a frame of reference. They blamed gods for what was happening all around them, because it was like the end of the world. It was like the gods had forsaken them in their experience. But all you have to do is realize who they were. They were uneducated and ignorant from our perspective. And so they blamed something that maybe wasn't completely accurate. But we shouldn't just ignore these geniuses, because There's a lot of evidence to suggest that we are right on the edge again here now. If you look at the magnetic field and how it's changing, we're just a couple of decades away at the current rate if it doesn't accelerate anymore. And I don't know why it would.
Very good, Ben. Now, I want to thank you so much for joining us today. That was very important. Great information for everybody to have. Is there anything upcoming interesting for you that you'd like to talk about before you head out?
The best thing you could do, it's free every morning on the Suspicious Observers YouTube channel. Update all of this stuff, what the sun, Earth is doing, space news. The Suspicious Observers YouTube channel is where all of this stuff is happening. And again, it is free.
Very good. Well, thank you so much again, Ben. And I'm definitely going to have you back on because there's a lot more stuff that I wasn't able to get to.
I apologize about that and for the breaking up of the call at times.
No, that's okay. We just wouldn't have had enough time anyway. There's so many fascinating things we could have discussed, but definitely I'll have you back on.
Well, awesome. Awesome. It's been a pleasure talking with you today.